Hello everyone. I hope you guys are doing good. Of course, you must have had fun and you will have it ahead. You will enjoy your so-called day. But however, being said that, I want you guys to spare some time in knowing what exactly is OMP and its attributes. As you are already aware, in last session we learned about SD-WAN, software defined WAN and its modules. In this session, I'll be covering most of the topic related to OMP and its attributes. So, as discussed earlier in the last session, what exactly is VBond? VBond orchestrator is nothing but software. So, as I've mentioned, the people nowadays, the people they generally, network administrator, they generally take care of management and maintenance, like upgradation or adding VHs. So they've got the access of the console wherein they take care of everything, like taking care of upgradations. But however, being said that, they are not even aware like what exactly is VPON. Is it a hardware or software? They never ever thought of indulging themselves into implementation or thinking about designing or implementation or installation of the devices. So being said that, we do have devices, we do have hardwares in data center and at the branch offices, but those modules those modules are nothing but the software based solutions that Cisco has came up with. So this particular module, it takes care of authentication. It's a one point authentication which takes care of controllers and edges. So it authenticates the Cisco vSmart controllers and the VH routers in the overlay network. So what do you mean by underlay and overlay? Underlay is something which is nothing but the hardware on which you have got the overlay network. Overlay network is nothing but the cloud environment. So you've got the hardware switches in underlay network, and it will be extended to the overlay network, which will be later on will be called as cloud environment. So vBond is a part of overlay network, and it coordinates the connectivity between them. It must have public IP address so that we can access it, and it will be helping to access all VH devices in the network which are connected to it. Again, SD-WAN vManage is nothing but a software based solution which takes care of administration. So SD-WAN overlay fabric is something which is nothing but VHs. Um, they are used to connect data centers, branches, campuses, and other facilities to improve network speed. So we manage it's a console. Administrator can quickly establish an SD-WAN overlay fabric to connect data centers, branches, campuses, and other facilities to improve network speed. So it's kind of software based solution. It is flexible and easy to deploy. So when we say we manage itself states that it will be helping in management and maintenance. It's a console wherein administrators can easily access the entire network. What exactly is vSmart? It is again software that runs as a virtual machine on a server configured with ESXi or VMware hypervisor software. The vSmart software image is signed image that is downloadable from the Cisco SD-WAN website. So vSmart, it's it's a software image or a virtual machine which will be taking care of control plane of the VHs. Now, being said that, like as I've mentioned earlier in the last slide about those modules, and what exactly are those modules, and their work. Uh, we also do use hardware, the hardware devices. So the entire network is made up of those three particular, or you can say that the entire network is segmented in between, in those three different major components, which are nothing but cloud, then core, and the branch. So branch is something which is nothing but access layer. The core is nothing but a distribution layer, and cloud which will be taking care of layer 3 or overlay network. So the basic devices that we have got in Cisco, or the SD-WAN edge platforms that we generally use for any deployment. In the virtual mode, we'll be using CSV 5000. If we'll use Viptela technology, Viptela has been merged into Cisco. It's been years. And if you wanna have SR series, then of course we've got ENCS 5000. And if you wanna have cloud scale SD-WAN IOC, then you will be using Catalyst 8200 series and 8000 series. In cloud mode, of course we'll be using that. I mean, in the underlay we'll be using that, and overlay we'll be using something different, of course. Core lay, we've got VH 2000, 5000, SR 1000, and branch you can use SR 1100, 4 gig, 6 gig, 8 gig LT, as it has already been mentioned in the slide. So how is the connectivity between vManage and V8? The entire Cisco SD-WAN is comprised of vManage, vBond, vManage, vSmart, VH. The entire Cisco SD-WAN, including vBond, vManage, and vSmart, they are at data centers, and the VHs we have got at the remote site. So we'll be extending it to the remote site, to the branch ends. So at the branch end, we'll be using IR1101, 1100 series. At a data center, we'll be using CSP 5200 series, 5400 series. This is 1100 series. This is just for your information. Like, you've got this SFP WAN RS232 serial port, mini USB console, LTE module, 4 fast Ethernet LAN ports, expansion module, LTE module. We will be discussing about this later on more in the next slides, or the in the next sessions, if you want me to explain in details, or else you can surf a bit. So what exactly is OMP? It's the protocol that we'll be using in SD-WAN. It is TCP based extensible control plane protocol. It runs between VH routers and vSmart controllers, and at between the vSmart controllers, between VH routers and vSmart, and between vSmarts. So inside we've got permanent TLS DTLS connections. vSmarts create full mesh of OMP peers. VH routers are not required to peer with all vSmarts. See, if VHs are they are connected with each other, and in return, if they are gonna get connected to one vSmart, then you don't need to have the other connection. VH controller discovery. So how does that exactly works? VBond is something which will be taking care of authentication. That's how the VHS will be identified, will be getting connected to VBond through vSmart. So controllers hold permanent sessions with VBond. VHS uses an interim session with VBond for controller discovery. The VBond location is statically configured. VH must learn the public IP and the port of the controller, which is dynamically updated during the life cycle. So VBond relation must allow for the registration of private and public information of the controllers. So in VBond you will be getting a controller list, the vSmart list. In return from vSmart you will be getting list of course edges, V edges, which is nothing but access layer switches. So how is the terminology that we've got vSmart in the cloud? Either the connection will be through MPLS or using INET to the VH, and later on it will be connected static, dynamic, whichever protocol that you will be using for the internal network, local network. As I've mentioned earlier in the last session about the VPN numbers, we've got the VPN 0 which we'll be using. The transport side will be using VPN 0. Traffic is always tunnel and encrypted unless we'll be using or we are interested in split tunneling. If we are going to use a split tunnel, at the service end we'll be using 512, which is reserved for management, 12511 at data center. Traffic is forwarded as is from the original source. T-Loc, it has got its attributes. It works on its own attributes, which are nothing but system IP, color, private T-Loc, public T-Loc. So the transport locators is nothing but the collection of entities making up a transport side connection. So OMP routes, they are tagged with attributes as the OMP picks up the routes. We've got the system IP, we've got the organization name. The system IP is nothing but 32-bit dot decimal notation. It is unique identifier of an OMP endpoint. Logically, a VPN 0 loopback interface referred as system. It will be the router ID for BGP and OSPF. Unless if you want to configure a specific router ID, of course. Organization name, it defines the organization unit to match in the certification authorization process. So we've got the certification authorization process in TLS encryption, DTLS. The OU is carried in both direction for authentication control and VH nodes. Site ID identifies the source location of an advertised prefix. So site ID is configured on every VH. Site ID does not have to be unique, but it then assumes the same location. We've got the different colors for identification. So we've got the private colors and we've got the different other public colors like red, blue. So we'll be using color for the identification, transport locator and colors. So if you have communication between VH to VH, the color setting will be different, and for VH to controller the setting will be different. If you're going to use a private color at the both sides, a private IP will be used and the port will be used to have an establishment in the form of tunnel. If there is a mix of private and public colors, a public IP and port will be used. So if both ends are private, it's gonna be private. If both ends are different, one of them is private and the other one is public, then of course public. When a tunnel is established between two public colors, public addressing as a tunnel source and destination is used. From VH to VH, either it would be connected using MPLS or internet, of course. The color does matter. Fabric operation, how it works from vSmart to VH. As you can see in this slide, from VH to VH, we will be using VPN 0. VPN 1 to 511 will be used at the vSmart level. And at the transport layer, you will be using VPN 0. In the local region, like for the local network in the branch offices that you've got, we'll be using VPN 1, VPN 2, and BGP, OSPF, or the whichever the routing protocol that you would like to use. Other than of course OMP, you will be using it from vSmart to VH. So T-Locs will be between VHs, and OMP update will be propagated from vSmart to VH. So either it will be OMP, or it could be DTLS or TLS, or it could be IPsec or BFT. I'll be explaining in detail, like when you say BFT, what exactly is BFT. The connection between VHs will be the BFT connection. DTLS is datagram transport layer security, and then transport layer security. I'll be detailing about DTLS and TLS in this slide itself. IPsec, you must be aware of IPsec. IP security, we've got GRE and IPsec tunnel. IP security or IPsec tunnel, it is more encrypted if compared with GRE. The connection between vSmart and VH will be OMP, or it will be using OMP protocol. So TLS and DTLS is nothing but like transport layer security, TCP plus security. In this security, you will be getting three um, you know privileges like integrity, authentication, and confidential. So we've got datagram TLS, which is based on TLS. SSL is nothing but the SSL protocol that we generally use. So we've got SSL and TLS. SSL is nothing but secure socket layer, and TLS is transport layer security. SSL, it has been developed in 1995, and TLS has been developed in 1999. SSL is not that secure if compared with TLS. It is cryptographic protocol which uses explicit connection to establish secure communication between web server and client. So it's the successor. TLS is something which is nothing but a successor of the SSL protocol. So what exactly is SSL? It will be using session key, secure socket, as the name suggests. And what will be TLS? It will be using key, and at the same time it will be taking care of cipher spec. What exactly is cipher? It is like more secure. it will be whatsoever the updates that it will be sharing between client end and server end will be upgraded versions of the previous updates. But in this case, it's not going to be like that. So when we say DTLS, what exactly is DTLS? Datagram Transport Layer Security. So what exactly is datagram? The data is transferred in the form of bits at the physical, in the form of frames at the data link, in the form of packets between in the network, in the form of segments, and then we've got SPDU, PPDU, and APDU. So when we say datagram, it is something which will be working at transport layer as well as at the network layer. It's a format. So we'll be having connectivity between vBond and vManage and vEdge and vSmart. We'll be using DTLS. So how it works is it's a tunnel authentication. So datagram transport layer security, it will be using CA sign certificate. Verify serial number or organization name and then whether the certificate has been signed by CA root or not. So we've got the OMP base path selection. The first one is route state. The second one route resolvability. Then we've got AD. We've got route preference. We've got T-Loc preference. We've got origin. Route state, of course, you'll be preferring active routes over stale. Route resolvability, next of T-Loc, it must be reachable. AD, prefer OMP routes with lowest AD. Prefer OMP routes with highest route preference. Prefer OMP routes with highest T-Loc preference. And best origin. So other than that, if all other OMP routes which are identical up to this point will be considered as equal cost. The tiebreakers are then used to sort the so-called OMP routes in descending order from base to worst. So in this session, we learned about SD-WAN terminology, the so-called protocol that we are using, the OMP protocol, and its attributes. What exactly is datagram? What exactly is TLS and TTLS and SSL? And also we learned about hardware, SD-WAN, which hardware devices we generally use in SD-WAN implementation. Uh, if you guys have any questions or any comments that you want me to add in the next slide, because in the next slide I'll be covering most of the session related to the so-called implementation right from the scratch. So if you got any questions related to whatsoever the terminologies that I have covered in last and this session, you can always shoot in the comment box. And if you want me to add any points that you think are appropriate, and the so-called audience will be also getting it, getting the so-called information that you will be adding in the comment box to increase their knowledge base will be appreciated. Thanks a lot. Have a good day ahead. Take care.